before taking the bones apart and looking at them individually. So in the front leg of the fox, we have the scapula, which loosely holds the limb to the trunk with muscle and fascia attachments. Humerus, the upper arm. Radius and ulna form the antebrachium, the lower arm. And to differentiate those, the ulna has the olecranon process, the elbow back there. And the radius tends to be a lot stronger and has kind of a little pointing edge that looks like a hand on the distal end, but we'll take a look at that individually. Then we have the carpals, metacarpals, and phalanges. There are a number of features on the scapula we would like you to know. Let's start with the flat surfaces. We have the spine of the scapula sticking up at kind of a 90-degree angle from the scapula. This spine always faces laterally. Above the spine is the supraspinous fossa. Below the spine is the infraspinous fossa, think infrared, below. On the back of the scapula, this is the side facing the rib cage, we have the subscapular fossa. And on the end that is articulating with the humerus, the head of the humerus, we have the glenoid fossa right on the end. Scapulae tend to have a triangular shape, and these edges are named according to their direction on the spine, or relative to the animal. So if you think about an animal's scapula as being a little bit more, we have the humerus coming down here. We have an anterior border. It's also called the cranial border. We have the vertebral border, which is also called the dorsal border. Remember the spine is oriented horizontally like this. And then we have the axillary border, or caudal border. On the spine, we have a few things to look at. We have the tuberosity of the spine, and this may or may not be very prominent depending on your individual and your animal. So it's kind of this crusty place. This crusty place on the edge of the spine. These two prominences down towards the upper arm looks like a pointing finger, actually. And if you make that shape with your hand, we have our pointer finger, that is the acromion, and the thumb sticking out to that side, that's the metacromion. So acromion, metacromion. Acromion, metacromion. Sometimes, if you look at the rabbit skeleton, the metacromion is crazy long. Look down at the edge, at the kind of the ventral side of where your scapula is oriented. You will see a little hook. In some of the specimens, the actual hook part has fallen off, but you can still see the arc of where it's going to be. That hook is the coracoid process. So think coracoid, like curly Q, the coracoid process. We'll see coracoids in the bird and coracoid bars in the shark. The axillary border, or the caudal border, tends to be flatter, but I wouldn't use that as a hard and fast. What I would do is orient the scapula so the glenoid fossa is pointing down towards the upper arm, and see which way is the spine facing. If we have the spine facing laterally and the glenoid fossa pointing down, this is a right scapula. We have an articulation between the scapula at the glenoid fossa and the humerus at the humeral head. So the humeral head is relatively triangular in shape. It's not quite as ball-like as the femur. If you turn the humerus so the head is facing you, you'll see a large crusty prominence and a smaller crusty prominence. These are the tuberosities. So we have the greater tuberosity, the larger crusty prominence, for a lot of muscle attachment towards the lateral side of the body. And we have the lesser tuberosity. So greater tuberosity, lesser tuberosity on either side of the head, kind of on the anterior portion of the humerus. Coming down from the greater tuberosity, if we angle this down, if we see this angled line here, that is the deltoid ridge. Deltoid is deltoid associated with the shoulder muscles. So we have this strong diagonal line coming down towards the front of the humerus. On the other side, so use your lesser tuberosity, which is facing medially. We have our midline here, our ribs are here. Lesser tuberosity, we have another slightly shorter prominence here, just a little bit of a crusty line. That is your pectoral ridge, and that's facing, again, we have our midline here, we have our ribs here, our pectoral muscles have a connection here. Deltoid muscles of the shoulder on the lateral side of the humerus, pectoral muscles on the inner side. As we travel down, we have our supracondyloid ridges, medial and lateral. The lateral supracondyloid ridge tends to be a lot more prominent. So that is the one we are naming. We have our lateral supracondyloid ridge. We have our olecranon fossa right here. This is where the olecranon fits in when you have the arm extended. We have olecranon fossa, where that olecranon process rests, right in here. The trochlea is this entire section on the posterior part of the humerus and wraps around to encompass this more projecting structure. The capitulum, if you look closely at it, the capitulum is just this anteriorly facing section here. So the trochlea, specifically, is what is fitting into our semilunar notch. The capitulum is where the little head, the head of the radius is interfacing. We have our epicondyles, and so these are crusty ridges, crusty prominences, spaces for muscle attachment above the condyles. Epi meaning above, condyles, the condyle articular space here at the elbow. Epicondyles, medial, lateral. This is not seen in all animals, but in felines, you'll see a supracondyloid foramen. With the fox, you do see this larger hole in the middle. That is the supratrochlear foramen in canids, and you'll see it in some humans. For the ulna, going through the parts, we have our olecranon process, again fitting into that olecranon fossa as we extend the arm. The semilunar notch, articulating with the trochlea of the humerus. And one side of the semilunar notch, the medial side, is very complete. The lateral side is interrupted by the radial notch. As you trace that U shape, you're going to be interrupted by the radial notch that faces laterally when you are looking down at the ulna in this perspective. The very tip of that radial notch, that is the coronoid process of the ulna, so the crowning process of the ulna. Highest point there. Moving down the ulna, we have this crusty ridge, which is the interosseous crest. And if we articulate our lovely radius, there's an interosseous membrane that stretches between the two. So it's a pretty durable ligament that's helping keep these bones together. The very end of the ulna, we have the styloid process of the ulna, and it's important to make that distinction because we also have a styloid process of the radius, right here. Moving proximally back along the radius, the head of the radius articulates in that radial notch. The neck of the radius is that narrower point just behind the head. The radial tuberosity is a slightly thicker part of the radius, a little bump here. The radius also technically has an interosseous crest, but we're leaving that on the ulna because it's a little more distinct. And then at the very end of the radius, we have our styloid process of the radius. To tell left from right, a really fun way of doing that with the radius is making a fist. The distal part of the radius, the part which has these knuckle-like projections, notice one side does not have knuckles, the other side does. Hold your fist like that knuckly side and kind of make a pointer finger. This is a right radius because that looks like a right fist making a pointer finger with the styloid process versus the left fist. The left radius will look like a left fist. Thanks so much for listening.